So let's understand HamsAI RAG system. So I have given the name as HamsAI just for understanding. So today we'll understand the demo about the assessment given. So first is system overview. So HamsAI is a fully self-hosted retrieval-augmented generation system for bilingual enterprise knowledge banks. So user basically asks questions in Arabic, English or mixed language, and the system retrieves grounded answers with source citations. No cloud APIs, no paid services, everything runs locally currently. Okay. Now there are three search modes as per the requirements. One is quick search, next is smart search, AI search, and thirdly it is an interactive AI. So one uses BM25 keyword retrieval, and second one is hybrid retrieval plus fine-tuned re-ranker plus local LLM generation, and lastly it is a multi-turn conversation. Okay. Now repository structure is something like this. So we will have this as a root name, and then we have readme.md. Demo.md is basically this, so I created to give the demo. And then model card md is for model specs, license, etc. Requirement is gives the Python dependencies. Docker is for Elasticsearch, Qdrant, Redis and Ollama. And then Docker file is for API container. Collab notebook is for fine tuning, which is ran on Google Colab using T4 engine. Now in scripts we have many Python scripts needed to do the requirement things. And in configs we have training and serving config, and in demo we have app through which we will see our web UI interface. Data is synthetically generated here, and if you see, this is the corpus of data currently. Models after fine-tuning I have downloaded and kept it here, and results are stored here. Okay. So to quick start we need to use this like pip install requirements and then docker compose up. And then we can build index and info, quick search, and you can do other things. Now to understand the architecture, we have something like this. So once user gives the query either in Arabic, English or mixed, what we do is we have three search mode, right? But currently this is like the unified way. So it goes through either of the search engines, and then it goes through either vector space, Elasticsearch or Redis memory. And after RR fusion it re-ranks the things and it gives the response using Ollama. Okay, we have this fine-tuned on Collab BGM3, which is then connected to Qdrant vector store. Okay, so that is how things work. But if you want to see each of the things, so for interactive AI we use load session, then LLM rewriter, smart AI pipeline, then answer follow-ups, and then save session. For smart AI we have like dual retrieval, RR fusion, fine-tuned re-ranker, Qwen 2.5 3B model, and then answer with citations. Then we have quick search, which is less than 100 milliseconds, but currently considering the CPU it's difficult. We have storage layer for this like keyword index, vector store, session memory and LLM survey. Okay, now fine-tuned models are this. I have stored it here. So if you see, these are the fine-tuned models I have created. Okay, and this is the notebook after and before accuracy and after accuracy we have got on the Collab notebook. Okay, so coming to the next, let's understand how we can quickly start the things. So what you can do is you can run python demo.app. I have currently run it here, it is still running. And in the Ollama, if you see, the window is running, Ollama is running here, and Windows PowerShell I can show you like docker ps, which shows us all the 4 containers, right? It is running like Redis, Qdrant and Elasticsearch is there. Okay, so all 4 are up and running. We just need to go and hit the AI. So currently this is the AI engine. Let me refresh it. Okay, now let's begin as per the demo. First we will do quick search. Okay, let me go through the interface. So we have 3 modes: quick search, smart AI search, interactive AI. We can also see everything is up. Okay, and we have search bar and we have clear filter. We have session ID for interactive. Quick search we don't have. We have examples. We can also ingest the document here and we can get the answers. So let's do the quick search for now. So we have this first query. Let's run this into quick search. Now since it is running on my CPU, it might take a lot of time because things are not that good here. So quick search first query, this is the answer. And secondly, let's try the English. So you can also see like it gives P1 returns and citations and other things, right? So this is the English one, technical support, SLA and other things. Okay, now let's try the mixed thing. Okay, which gives us this result. Okay, so quick search works fine. Basically it gives everything: search, total milliseconds, citations, etc. Now let's move to smart AI search. So first we can see the Arabic number. Okay, so it gives basically answers is Arabic, warranty duration, working days. It gives basically this citation. Okay, so let's see, it will take some time here for smart AI search to work because again internally, see, it is running or pumping up. It might take some time, but yeah. So if you see warranty AR002 and the relevance given, this is the first Arabic numbers. Now let's see query 5, which gives like multi-point answers, right? So this is how it works. So let it load. So it will give these kind of outputs. Okay, like JEDA core, Demon, smart desk, etc, etc. Okay, now let's copy the next query in case grounded refusal, right? So if you see these are the things it gives for this. Now this, it doesn't have anything to prove that our model is not hallucinating. So if you see we will get this kind of output, right? So let's see. Till then I will copy the query 7. If you see, it is giving. Okay, now let's check query 7. It gives English batch like multi-sentence answer with inline 1 to 3 citation marks, and then severity. It will also give the sources like SLA EN001. Okay, something like this. So yeah, if you see this, it gives. Okay, so this is how it works. Now let's check like mixed Arabic query, which is the query 8. Okay, I think okay, let it run. Now after this we will move to like interactive AI search, but let's see how things go. So this is how it gives the answer with respect to the mixed query. Okay, so it pulls API EN001, which is this, right? And it also gives us everything like retrieval, re-rank, time to first token, and total milliseconds needed. Okay, now let's move to, it is saying start completely fresh session ID, but for now I think we need here. Okay, so I will use this as a warranty topic. Let me paste here. Now session ID is not there, but once the query is given, it will start the session here and the session ID will be created here. You can also see the logs here. Everything is working fine because 200O gives the response as okay, right? So let it run. So this is the first interaction. Now let me give the, it will give something like warranty AR002, right, which is correct, and then turn true. Let's give this. Now if you see session ID is created here, I will give turn 2 here. Till then it will give something like this, 4/8/2026. Okay, let's see. It will take some time because it is searching through things. So yeah, it is working fine. Okay, 8 4 it is giving, so it is working fine. So if you see, this is turn 2. Now let's give turn 3, which is like the English one. Now we are changing the language actually. Okay, and we are searching it. So let's see how it gives. Here we will see the code switching detection, and it will give us like warranty mixed 026, something like this. Let it take a couple of minutes. Okay, one thing is, since we're running on my personal laptop, it might take some time, because again, so it is giving in this kind of answer. It gives HamsAI core CRM, which is correct, and then warranty mixed 026, warranty AR001 it is given, which is correct. It did not give this part, but it gave this part. Okay, cool. So this is how I tested everything, and currently the corpus is small. That is one drawback. Secondly, this is the CPU measured values with respect to everything, and then we have chunks here. Corpus size scalability can be done, and these are the results after model fine-tuning, like before and after. Since the corpus was small, fine-tuning takes some time. This is the output, and then re-ranker lift after deployed pipeline on the 200 pair test set is this. Okay, so knowledge bank is this, like 240, 80 Arabic, 80 English, 80 mixed. Chunks are this, which is very minimal actually. It should work fine, but then again, it takes some time on the local setup. It takes a lot of load because each model is around 2 GB and it requires a lot of space, right? So those are the things. So yeah, so this is the entire demo of the RAG system. Hope it was helpful, and yeah, thank you.